All right, well, good afternoon, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 99 is on the screen. Is it 99 or 100? Yeah, right? And number 1 is for measured variation, and number 2 is a quick review on one of the sessions from last week, just to get us going today. Today we're moving on, just to add a couple more things to that. So copy and go. All right, for the sake of time, turn that in as soon as you can. Agenda for today, warm-up number 99, discrete probability distribution. And your home plate for tonight, only 2 problems. And today we're just going to add a couple more things for of what we did last week. The only thing today, we're just going to tweak it a tiny bit, which I don't know if you're listening between the lines, which I'm saying that we're getting another formula. Let's go, let's go. One more formula, let's go, right? All right, get a Cornell note going. Our objective for today, I can define and compute the discrete probability distribution. I can define and compute discrete probability distribution. All right, so with that said, where have we been? Once again, we talked about definition of probability, the 3 different probabilities that we've been working with. We talked about variables, random variables, and we talked about that we were going to focus on discrete variables. From there, we went to discrete probability distribution, which was a table specific for our distribution. From there, we talked about formulas for discrete probability, and here are the 3 that we used. It changed a little because now it was applied to the discrete probability distribution table. From there, we talked about binomial distribution, and by binomial, meaning how many outcomes, tell your neighbor. How many outcomes, everybody, if it's binomial? 2. Well, guess what? If there's such a thing as binomial distribution, what do you think multinomial distribution means? 2, more than 2, yes? All right, so copy this. Let's go, let's go. copy the formula, please. Hey, party, let's go. Man, you guys come up with the greatest ideas. Anyways, copy that, please. Give you some time. Go. Yes, Mr. Q. All right. So, before I move on, though, this is very similar to what we did last week. However, look at it. Look at the formula. Don't look at anything else. Just look at it. Bless you. Look at the formula. Tell your neighbor what's missing from last week to this week. What is missing? What's missing, JC? No, I'm over here. See, it's pretty good, right? That is correct. The complementary of the probability is missing. So, however, today, if you notice, we have multiple outcomes and multiple probabilities that we need to be dealing with. So with that said, here we go. Let's get started. Example Q. I'm going to leave the formula down here. And it reads, in a large city, 50% of the people choose a movie, 30% choose a dinner and a play, and 20% choose shopping as a leisure activity. If a sample of 5 people is randomly selected, find the probability that 3 are planning to go to the movie, 1 to play, and 1 to go shopping. So for this one, do copy that, please. I want you to have at least one example for your own. Copy the problem, please. I'll give you some time. All right. So with that said, y'all ready? So let's get started. Start with N. Tell your neighbor what N is. Everyone? What is N? 5. That is correct. All right. Next. I don't know if you guys noticed, but now we have how many, what are they asking us to find? Probability of what? 3, what else? 1, and 1. So that means we have, look up, x sub 1. What else? X sub 2, and x sub 3. Now instead of just 1x, we have 3 different ones. That's why it's called what? Multinomial. There you go. Let's go. All right. So for the first one, they're asking us probability of 3 planning to go to the movie. 3. 1 to a play. And 1 to the shopping mall. So with each of those, we have to write the corresponding probability. So I'm going to highlight this one is was probability of 3 planning to go to the movie. All right. So what is that in percentage? Yes, 50. So how do we write that in decimal or fraction? 0.5. All right, so that's its corresponding. That means we need to find P2 and P3. Tell your neighbor what those are, please. And we got what? 0.30 and 0.20. Okay. So now that we have all this, let's set up our formula. And you can leave it as P of X, that's fine, because it's got too much stuff to write in there. All right. So, Zach, what do I write on the numerator? Okay. How about the denominator? Yes. Thank you. Yes, times and times. Times. It reads P of 1 to the X of 1. Tell your neighbor what to write next in parentheses. 0.50, yes. To the what? To the third power, okay. Times. Everyone. 0.30 to the first. And last but not least, 0.20 to the first. Okay. All right, calculators. This is 20 times this times that which is 0.30 times 0.20. Who's got 0.50 to the third? Is it 12.5? Or 1.2? Bless you, 0.125. So, P of X equals 15% or 0.15. Yes. Yes, 15%. All right, from 1 to 5, how comfortable are you with this? Yeah, you just need to make sure you set up your x of 1 with their corresponding probability. I'm going to give you one more. Don't copy the problem, but set up your values first, set up your formula, and come up with your overall multinomial, multinomial probability, and then I'm going to give you one that's a little bit different. So here goes the next one. Example omega cube. It reads, a small airport coffee shop manager found that the probabilities a customer buys 0, 1, 2, or 3 cups of coffee are 0.3, 0.5, 0.15, and 0.05 respectively. Can you remember what respectively means, please? Okay, good. It means this, that for this is this, for this is this, for this is this, and of course for this is that. If a customer enters the shop, find the probability that 2 will purchase something other than coffee. 4 will purchase 1 cup of coffee. 1 will purchase 2 cups, and 1 will purchase 3 cups. All right? I'll give you a head start to set up your values first. Like I said, you don't have to copy the problem on your paper, but start setting up your values, and then we'll go from there. Give you a head start. Copy it. All right, I think we got it. So let's see. What is N? 8, okay. All right. Now, how many probabilities are they asking us to find? They're asking us to find, let's see, 1, 2, 3, 4. So that means x of 1, x of 2, x of 3, x of 4. Okay, so let's see. Probability that 2, okay. Probability that 4. Probability that 1 and 1. Okay. Did you set that up by yourself? Yes? Okay, good. So we need P sub 1. Let's read first the first one. It says, find the probability that 2 will purchase something other than coffee. What does that mean, other than coffee? That it's 0. Okay, so which one corresponds to 0? 0.3? Okay, so it's 0.3. That is correct. Good afternoon, Ms. Q. Hi. All right, so what did we say? Oh, that's 0, coffee, that's 0.3. Then it says 4 will purchase 1 cup of coffee. What is corresponding to 1? 0.5, so this is P2. 0.5 or 0.50. 1 will purchase 2 cups, so P3. 2 cups is how much? 2 is 0.15. And the last one, P4, is 3 cups. 3 cups corresponds to 0.05. 0.05. And by the way, I don't know if you saw the the small print on that formula, when you copy the formula, it says that all the probabilities have to add up to how much? Tell your neighbor again. Very good. 1. Yeah. All right. And also all the outcomes, or the x sub 1, sub 2, sub 3, all of those have to add up to n. Yes? All right? So set up your formula now that you have those values. Once again, P of x equals That's you. All right, help me set this up. Jet, what do I write? That is correct. And I'll give you guys some time to get that. See what you get. All right, so what you get at the end, Dom? P of x for the multinomial is? Okay, we'll leave it at 0.035. And percentage is 3.5%. Hands, have you got that? That is correct. Let's go. All right. So far, so good. So let me show you the last one. The last one's a little bit different. I just want you guys to talk through it to make sure you know how to approach them, because these are pretty straightforward, the ones I gave you right now. Okay? So look at example super cute. It reads, a box contains 4 white balls, 3 red balls, 3 blue balls. A ball is selected at random and its color is written down. It is replaced each time. Find the probability that 5 balls are selected. If 5 balls are selected, 2 are white, 2 are red, and 1 is blue. All right. Talk it over your neighbor. Let them know what each part is and see how they got each component. I'll give you guys a head start. Be careful, this one's not straightforward, so there's some computing that you need to do on these. Okay, let's go with the easy one. N is what, everyone? 5, okay. All right. Then we got how many are they asking us to find? 1, 2, 3. So we got x sub 1, x sub 2, and x sub 3. Okay, so far so good. So we write what? And 1. Okay. Here goes the fun part, though. All right. So probability of a white. We're not looking at this yet. Just what would be the probability of a white? 4 out of 10, that is correct. Let's go! Which means the probability of a red is what? Yeah, 3 out of 10. And of course, P out of 3 for the blue, it's also what? 3 out of 10. Do we know what to do with that? Yes, Mr. Q. Decimal value for these, this is what? 0.4, 0.3, and 0.3. That is correct. All right, so I'm not going to have you do the whole thing since you already know how to use the formula. We already did a couple. From 1 to 5, how comfortable are you with this? Yes, 5, 5, okay. Here's a home plate for tonight. Get your phones out. It's only 2 problems. Only. So one of them is on M&Ms, there you go, and another one on truck inspections. All right, we'll stop right there. I'll stop the video right there. Also, those of you that are following along on YouTube, just make sure you get some practice in with these, and see you guys next time. Bye.